Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. N-ary tree Postorder Traversal, Leetcode 590. In this problem, we are given the root of an N-ary tree and we have to return the Postorder Traversal of its nodes values. N-ary tree input serialization is represented in this level order traversal. Each group of children is separated by null values. So what they say is like the root that we see here is like a level order traversal of the visual representation. So we will look at the visual representation now. We know that binary tree has at most two children, left and right, right? And but n-ary tree can have more than one children. So it can be 0, 1, 2, 4, 5, any number of children. So basically it has a list of children. And then those children will again have the list of children and so on. Now the post order involves visiting the parent or root after the children. So that is why it is called post order. For example, in binary tree, post-order traversal involved visiting the left child first, then the right child, and then the parent, right? Similarly, in the n-ary tree, the post-order traversal involves visiting all children of the node before visiting the node itself. In this example, we can see that the post-order traversal is 5, then 6, then its parent, that is 3, then its siblings, 2, 4, and then finally the parent, 1, right? So the order is 5, 6, 3, 2, 4, 1. In a binary tree, we visit the left child first, then the right child, and then visit the parent, right? Similarly, in case of n-ary tree, we will have a similar logic. Instead of visiting left and right, we will be visiting all the children nodes from left to right, and then visit the parent. And now let's see that with the code. Let's start with the recursive approach first, and then we will move on to the iterative approach. So first thing we will do is we will just create the answer list. Now we check if given root is null. If that is the case, we will just return the empty answer. Now we have to do the DFS, that is post-order traversal. So in this case, let's define the helper function. So we will just pass in the root and answer. And in the end, we will just return the answer. Now let's write the helper, which will actually populate the answer list. We will pass node root in it and list answer in it. So now we have to first process the children and then the parent, right? So we will start iterating on the root's children and pass it to the helper method. So it will be child and answer. And after we are done with this DFS, we will actually add the current node to the answer. That's it. And we don't have to add the node, we have to add the node's value. And that's it. We are not returning anything. We are just updating the answer list. And now let's run this code. Cool. Let's submit this code. Awesome. So in terms of time complexity, it will be O of n, where n is the number of nodes in this n-ary tree. And the reason is we are going through each node only once when we are actually going through this loop or when we are adding the node value to this answer list. And in terms of space complexity, it will be O of height because the depth of the recursion at each level will be the level of the tree. So we are running this loop and then going to the next level of recursion. So that is why it will be O of height. For balanced tree, it will be logarithmic, but for the unbalanced tree, again, it can go till O of n. And now let's switch to the iterative approach. And again, there can be multiple iterative solutions possible. One thing is for sure that we need to have the stack, right? Because we need to post-process the nodes. But the problem is we are given the root of the tree. But in the output, we need the children first. And then the next thing is, once we are given the root, we have to add the corresponding, then you have to add its children, but we are not yet done because if this children also has a children, we have to go one level deeper and continue doing this, right? So how about we push the root node on a stack initially? So this will simulate our recursion. And then when we pop this node out from the stack, we process it and we push all its children to the stack. So this helps us to continue the recursion, but we are processing the parent before its children. And in post-order traversal, we want parent processing after its children, right? So to fix this, instead of adding the process node values to the end of the list, how about we add them to the front of a list? And not just any list, it should be linked list because we want the efficient addition to the front, which takes O of 1 time. In case of array, if we add the element, we have to shift all the elements to the right then, and that takes O of n time. So linked list is the preferred choice here. Another way can be that we actually append the answer to the list, but then reverse the list in the end before returning the answer, of course. So now let's look at it with an example. So let's draw a stack for recursion and list for answer. It's not a array list, it's a linked list because In linked list, prepending a node at head takes O of one time, where we have to break the list and then make this new node head of the list. So both the operation takes O of one time. Now initially we see 1, so we actually push it to the stack. Now we start the iteration where we pop this element out of the stack, prepend it to the answer list, and push all its children to the stack. So this ensures our logic continues similar to recursion, and we will continue doing this till our stack is not empty and all the elements are processed. So now we push in 3, 2, 4 and prepend 1 to the list. So our linked list has 1 now. Then we pop out 4 from the stack, right? And 4 does not have any children, so we prepend 4. Then we pop out 2 and we can see that 2 also don't have any children. We prepend it to the list. Now we pop out 3 and we can see that it has 2 children, 5 and 6. So we push them to the stack, or let me write it this way, and prepend 3 to the answer list. Now we pop out 6 and it does not have any children, right? We prepend it to the list, and then similarly 5. We pop out 5 as well, it does not have children, and we get 5 at the start of the list. So this is how we can actually get the post-order traversal. And note that we can actually use a similar technique to get the pre-order traversal as well, but we will cover it some other day. Now let's jump into the code part. Now in terms of code, first thing we will change is we will change answer from using array list to linked list. I think this part can stay same. Now we have to create the stack for simulating the recursion. So we can just use DAC for that. And I'm passing the node rather than node value because I need its children for the next level of processing. And now we will push root to the top of the stack and start the iteration. So while stack is not empty, we will pop out the current element from the stack and prepend it to the answer list. So we will just do answer.add first. So that actually prepends the value. This is a method available on the list. And now we can actually use this for loop and I can get rid of this code. And now we will push children of current onto the stack for further iteration. That's it. Now let's run this code. Oh, time limit exceeded. That means there is an infinite loop for some reason. Because I'm doing root.children rather than current.children. Because of this, the stack was not getting empty. Now let's run this code again. Awesome. Let's submit this code. Cool. It looks a bit slower, but in terms of time complexity, it is O of n again, because we are visiting each node in the tree only once. And in terms of space complexity, it is again O of n, because in the worst case, a root node can contain n-1 children, and then we have to push all the nodes onto the stack, which will take O of n space. So to summarize, we have discussed two methods of N-ary tree: post-order traversal, recursive as well as iterative. I prefer the recursive solution because it is simpler to understand. But iterative approach actually uses a mix of stack and linked list, so we can also showcase it in the interview. And sometimes interviewers also ask the solution in iterative way. So it's good to know both the approaches. Thank you for watching. If you find this video helpful, please like, share, and subscribe. If you have any questions or suggestions, feel free to leave a comment below. Thank you. Have a nice day.